Hello, good evening, good morning, everyone. We are going to start a new series on Apache Spark. So, before we go and touch base with the actual concepts of Apache Spark and the series of Apache Spark, so I would like you to introduce with Apache Spark core architecture. Spark, if you spin up a Spark cluster, how Spark cluster would look like, and why actually we need Spark. Okay, these are the three different concepts that we are going to see in this introductory video, and going forward we'll see in-depth Spark series. Okay, so with that note, let me start with the core architecture explanation. On the underground layer, which is the backend critical layer, which is called the Spark engine, which takes the heavy lifting of lot many things. And on top of the engine, there are a lot of libraries segregated very neatly, which is called Spark SQL. If you want to write some kind of SQL like syntax and then play with the data frames, that is where the Spark SQL comes into picture. And then people who are very much accustomed with SQL and then playing with SQLs, they can actually leverage the capability of Spark SQL to play with the data frames. And Spark streaming, so you have a very real-time scenarios, like you have some IoT sensors set up. So IoT sensors are if you see that temperature sensor, humidity sensors, vibration sensors in the industrial heavy machinery and all. So they send too much of data, like they send it like for every second. They are calibrated to send a huge stream of data actually. So if you want to process such kind of a stream of data in real time and then store it for further analysis, that is where like Spark streaming comes into picture. Spark ML, so as I said, now your streaming is done and then you have some processed data, and then you want to do some kind of a machine learning logics on top of that data, and then derive some predictions or classifications out of it. Example, by seeing the vibration data, you can say whether the machine is damaged or machine is not damaged. A kind of an example for classification problem, which is most real in scenario. So for that, like you can use Spark ML. And then this is a graph X library, which is used to compute the graph database, graph computations, or graph data structures. Basically, I don't have too much of knowledge on how actually this is being used, but at the end of the series, definitely I'll search for some real-time scenario and then I'll also explain this graphics library. This is about the core architecture of for Apache Spark, how it looks like. Coming to, let's say, we are spinning up a Spark cluster in Databricks or Azure, or in Amazon. This is how it looks like. So you have a Spark driver manager. Basically, this acts as a Spark context, and then that actually controls two things: one, the cluster manager, and then the worker nodes. So any task that is being assigned to Spark eventually runs in a worker node, but the Spark driver manager and cluster manager are responsible to manage these worker nodes. So what is the health of the worker node, what is the load on the worker nodes, whether the node is healthy, is not running out of the resources or not, how much task has been progressed, how much is pending. So all these kind of different metrics are being managed by cluster manager as well as Spark driver manager. So the actual task that is assigned, example, you take that you are writing an SQL query or SQL Spark SQL frame, syntax over a data frame, and then you submitted that. So it eventually runs in something called an executor in one of the worker nodes. So let's say like you have a two node cluster. So you have two worker nodes cluster inside some cloud machines, So out of these two nodes, in one of the node, the executor picks that particular task and then it will start running. So executor can have n number of tasks, and each task will run on its own JVM. Basically these runs on JVM because internal to the Spark, the core logic has been written in Scala is basically a JVM based language. Okay, so that is how it works, and this is how the cluster architecture would look like. So but in our we don't need any cloud going forward, and for the complete series we would be working on a single node cluster, that is our local host. So we'll set up the PySpark inside our local machine for a single node system, and then we'll try to submit some jobs as well. We'll run with some PySpark PySpark SQL, and then we'll also run with SparkML. And even in the series we'll try to integrate Spark with the cloud services like Azure Blob Storage and other services. So how Spark would actually interact with the cloud services or cloud storages in fact, and then pull the data, and then it will try to process them. That also will see it. Coming to why Spark, basically, so I have four reasons to choose Spark. Spark is first of all scalable. So now once you see this architecture, you know that I can scale my nodes if at all this is being hosted on a cloud. So these days cloud, you know that scalability is one of their biggest advantage. So I can scale it such that like your parallel processing or parallel computation, the capability of that would increase. Obviously once you have scalability, your reliability will get increased, because one of the worker node or couple of the nodes are down, the task can be assigned to some other nodes and then it can be computed there. So your reliability increases. And then the speed. So as I said, like since you are hosting this on clusters, so you choose your own resource capacities, so that's the reason it's more fast. And as well I said, like it is like it computes the data parallelly, so it's like speed. And the last but not least is before Spark we used to do all these computations over something called Hadoop MapReduce. So Spark replaces that particular Hadoop MapReduce concept. MapReduce is a little tough, I can say, and then the learning curve is too huge there. But whereas coming to Spark, the curve of learning, which I said, like that reduces very drastically, and it is very easy to understand and then run. So to follow the entire series, I choose the language of Python. So we'll be using PySpark. If else like you people are more familiar with Scala, you can even run with Scala. Syntax would be pretty much almost same. Or even if you can run, if you are more familiar with Java, you can even run in Java as well. Okay, so Spark has got all the flavor support, like it can be run in Java, Scala, Python, all those things. Okay, and now before the next series, next tutorial that we release, to start the series, I would like you guys to go through this installation guide. Very pretty straightforward installation guide for PySpark. Since I told like I will be following with Python, so it is PySpark obviously. So this installation guide will tell you how to install PySpark on your local machine, and then make that ready for our PySpark programs to be up and running. Okay, so I'll post this link in the description of this particular video, such that you can go through, install it, such that from the next video onwards along with me you can also play hands on the PySpark. Thank you.